We send out signals, launch probes, and scan the skies, but still, nothing. No signs of intelligent life. This cosmic silence, famously known as the Fermi paradox, asks a simple yet deeply unsettling question. If the universe is so vast, so old, and filled with countless stars and planets, then where is everyone? Although often attributed to physicist Enrico Fermi in the 1950s, the idea dates back to 1933 when Russian scientist Konstantin Tsiolkovsky raised a similar question. He wondered why, in a universe brimming with possibilities, no alien civilization had made contact or even visited Earth. But rather than concluding we're alone, he offered a provocative theory, what we now call the zoo hypothesis. Perhaps advanced extraterrestrial civilizations know we exist but intentionally avoid us, observing us from afar as we evolve, much like scientists watching animals in a protected reserve. Since Tsiolkovsky's time, science has taken tremendous leaps. We've now discovered over 5,000 exoplanets, many within their stars, habitable zones, where conditions could allow liquid water. But finding life is far more complex than just spotting planets. A planet must possess the right atmosphere, the right chemistry, a stable orbit, and billions of years for life to evolve. It's like trying to count every grain of sand on Earth using just a teaspoon. Let's do the math. The Milky Way alone contains an estimated 100 to 400 billion stars. Around 5% to 20% of those are Sun-like. Taking the conservative estimate, 5% of 100 billion, that gives us 5 billion Sun-like stars. If 22% of them host an Earth-like planet in their habitable zone, that's about 1.1 billion Earth-like worlds in our galaxy alone. If just 1% of those develop life, we're still left with around 11 million potentially life-bearing planets. And if only 1% of those evolved intelligent civilizations, we're still talking about over 100,000 intelligent societies, just in our galaxy. Given the vastness of time and the speed at which civilizations could theoretically expand through space, shouldn't we have heard from at least one of them by now? Human civilization has gone from horseback to space travel in barely a century. Imagine what a species could achieve with a 10,000-year head start. The fact that we've heard nothing could suggest something terrifying, or profoundly enlightening. This brings us to the Kardashev scale, proposed in 1964 by Soviet astronomer Nikolai Kardashev. It measures civilizations by the energy they harness. Type 1 civilizations can use all the energy available on their home planet. Type 2 civilizations can harness the full energy of their star, perhaps through massive structures like Dyson spheres. Type 3 civilizations would use the energy of an entire galaxy. Humanity? We're not even a Type 1, we're roughly 0.7. Some expanded versions of the scale go as far as Type 7, encompassing beings that could manipulate multiple universes or dimensions. If even a tiny fraction of intelligent life makes it to Type 3, then there should be visible signs, altered star systems, megastructures, or strange anomalies. But we see none of that. So again, where is everyone? This leads us to one of the most sobering theories of all, the Great Filter. Coined by economist Robin Hanson, it suggests there's a stage, or multiple stages, of development that is incredibly difficult to pass. It could be the leap from simple to complex life, or from intelligent life to interstellar society. If the Great Filter lies ahead of us, it could be a catastrophic hurdle we've yet to face, such as self-destructive technology, climate collapse, or rogue artificial intelligence. If it lies behind us, perhaps in the formation of DNA or the emergence of multicellular life, it means we may be among the very few to make it this far. Hansen outlines 9 major evolutionary hurdles, ranging from the right star system and abiogenesis to tool use and space colonization. We've passed many of them, but we haven't mastered interstellar travel or even permanent off-world colonies. If the final hurdle proves too high, perhaps no civilization ever survives long enough to reach the stars. If alien life exists but can't communicate or expand, the silence could simply reflect universal fragility. But if we are among the first to cross the Great Filter, then maybe we're pioneers in a quiet, waiting galaxy. Even the discovery of primitive alien life, like microbes on Mars, or beneath the icy crust of Europa, would radically change our perspective. It would suggest life arises easily, and the real rarity is intelligent life that endures. But if we find no life anywhere else, not even microbial, then maybe intelligent beings like us are exceedingly rare, or we're alone. Until we have more data, until a signal is received or alien microbes are confirmed, the Fermi paradox will remain one of the greatest unsolved mysteries of our time. Are we a cosmic fluke? Or are we part of a larger story that hasn't yet begun to unfold?